Okay, this is exam 2 for physics 102 for spring 25. Here, first I want to redraw this circuit so that it just sort of looks more typical. My 12-volt battery, I come to a 3 microfarad capacitor, and then at this point I break into two parts of this parallel branch, and then I recognize that it comes back together over at this section. So I just sort of looking at the layout of this, I see that I have one capacitor that is in series with these capacitors that are in parallel, or rather I have one that's in parallel with two that are in series, and then that is in series with these capacitors that are also in parallel. So um, let's see how that looks as I lay it out. When I come to this junction, I have two branches. On the top one, I have a 3 and a 6 in series. And then on this branch, I have a 1 microfarad. And then at this point, where I have these look like two junctions, but because there's nothing in between them, I can collapse it all down to a single junction, and that's what I've done here. And then it breaks into two different branches. One has a 2 and 2 in series, and then the other has a 2 microfarad in parallel with that, and then that's 12 volts. So now I can begin to find the equivalent capacitances. The 3 and the 6 in series up here, right? 1 over 3 plus 1 over 6, that's equal to 2. And then the 2 and the 2, 1 over 2 plus 1 over 2, that's equal to 1. You can probably actually begin to see how this is going to shake out, where I'll have a 3, and a 3 all in series with one another. Anyway, so I have my 3 microfarad, and then I have a 2 and a 1 in parallel. And then a 2 and a 2, or excuse me, a 1 and a 2 in parallel. And then to find the equivalent of these, it's just 2 plus 1 and 1 plus 2. So I have 3, 3, and 3 all in series. All right, I could find the equivalent. In fact, the equivalent's not that difficult to find. It's 1 over 3 plus 1 over 3 plus 1 over 3, which is just 1 microfarad. That's 12 volts. Or I could say here just that because these are all identical capacitors, they each split the voltage evenly. So I have 4 volts there, 4 volts there, and 4 volts there. So I'm going to just write this. That's just copying that over. And if I have 4 volts across this capacitor, then I also have 4 volts here and 4 volts here. Likewise, 4 volts here and 4 volts here. Uh, so I want to know the voltage across C5. That is this capacitor, which is the same as this one, which is the same as this one. So that's just 4 volts. And then I want to know the charge on C2. Okay, that one's a little trickier to get. So I want to know the charge on this capacitor. So I need to find the voltage on that capacitor. Actually, no, this isn't tricky at all. Never mind. So to find the charge, um, well, I just say that the charge on this capacitor, Q, is equal to C times V. That's 2 times 4, so that's 8 microcoulombs. But because these two capacitors are in series, they also have 8 microcoulombs. 8 microcoulombs. So the charge on C2, which is this 3 microfarad capacitor, is going to be 8 microcoulombs. Okay? All right. Um, Consider this circuit. I want to know the voltage across R5, current through R1, and the power dissipated across R2, or in R2. Let's first just find the equivalent. Let's see if I'm going to do this. I'll do this down here. I'm going to go ahead and find the equivalent of that 2 and 2 in parallel. That's going to be 1 ohm. And then I'll also find the equivalent of this is 1 ohm, and then so that's going to be 1 plus 2 is 3 ohms. It's 4 ohms, 6 ohms, and then that comes back to my battery, which is 12 volts. First, want to realize that the current through R1, that's the total current. So whatever that current is the total current. And then the voltage across R5 is the voltage across this resistor right here. Okay, so the 3 and the 6 in series, in parallel, is an equivalent of 2 ohms. So that means that my total resistance, my equivalent resistance, is going to be the 4 and the 2 are 6 ohms. That's 12 volts. That means that my current here is equal to V divided by R, that's 12 divided by 6, or 2 amps. So I have 2 amps that is coming through this circuit. Not 2 ohms, I'm sorry, 2 amps. 2 amps going through that circuit. That all, by the way, is also the current that's going through R1, so I'll go and write that answer there, 2 amps. I need to find the voltage across R5. That is going to be the voltage here. Let me, actually, I probably want to draw the intermediate circuit. I was trying to skip a step there, but it's probably not a good idea. When I get this 12 volts, realize that I have 2 amps going through this circuit. That means I have a voltage of I times R, 2 amps times 4 ohms, that's 8 volts. 2 amps times 2 ohms, that's 4 volts. So those are the voltages across each of those individual resistors. I have 8 volts here, and across this whole thing, I have 4 volts. That means I have 4 volts here. So the voltage then across R5 is going to be 4 volts. And then the power dissipated in R1, well, if I look at this part of the circuit right here, this one's the more difficult question right here. I have a 2 and a 2. Oops, sorry. I have a 2. Actually, I have a 1 and a 2 ohm resistor. A 1 and a 2 ohm resistor. And I know that across them, I have a potential of 4 volts across the two of those. So I can imagine this, oh, shoot, sorry. I can imagine this as just being connected up to a 4-volt battery. Let's make this clear what I'm doing here. I have this part of the circuit right here, and I want to know what is the power dissipated across this resistor. So I need to find the voltage and or the current in that resistor. Voltage is fine. And then to get that, I realize that across this whole set of resistors, I have 4 volts because it's in parallel with this part, and so those have 4 volts, which is also the voltage across the equivalent resistor, that 2 ohm resistor right there. So I have 4 volts there. Now, I want to find the voltage across each of those individual resistors. I'm going to imagine this simpler circuit. Right here now I have 4 volts uh, across 3 ohms. That means that I have a current equal to V over R, or 4/3 amps. That means that my voltage, which is equal to I times R, across the 1 ohm is going to be, well, um, 4/3 times 1, or 4/3 volts. And here it's going to be 4/3 times 2, or 8/3 volts. So across that 2 ohm resistor right here, I have 8/3 volts. Let's go back up to our big circuit. Actually, I have 4/3 volts. So across these two resistors, I have 4/3 volts. Because they're in parallel, they have the same voltage. So each of them also has 4/3 of a volt. Now, if I'm looking for the power dissipated in R2, I know that R2 is equal to 2 ohms, and I know that V2 is equal to 4/3 volts. Power is equal to V squared over R. That's equal to 4/3 squared divided by 2 ohms. That's 16 over 9 divided by 2. That's 8 divided by 9 watts. So the power dissipated across R2 is 8/9 watts. 4 volts, 2 amps, and 8/9 of a watt. Um, or if you want to present that, it's 0.9 watts. Okay. Consider this multi-loop circuit. Give the magnitude and direction of each current. So first I want to just identify the loops that I'm going to analyze. Because there's no resistor in this left-hand branch, I'm going to use the left loop and the big loop. Oh, I also need to pick the directions for my currents. I'm just going to do that. No reason for picking these directions. It's just sort of the way I feel this morning. Let's do first the left loop. I'm going to start here and go in that direction. So that's going to be +4. I'm doing the left, so now -2 -2I2. I'll go ahead and solve this for I2. 2 minus 2I2 is equal to 0. That means I2 has to be equal to 1. It's +1. Let's do the big loop now. The big loop, I'll start here and go in the same direction. 4 plus 4I3 is equal to 0. That's simple. So that means that I3 has to equal to -1 amp. Okay, so I already know what I2 is. I2 is 1 amp. I had chosen I2 to be up. It came out positive, so it's up. I3 is 1 amp. I'd chosen I3 to be down, but it came out negative, so that's up. Now finally, I want to use the junction rule. I'm going to pick a junction right here. Recognize my currents are going in these directions. So that is I2 equals I1 plus I3. And then I can put in I2 and I3. I2 is equal to 1 amp equals I1 minus 1 amp, which is I3. That means that I1 is equal to 2 amps. So I1 is 2 amps. It came out positive, so that means that it is down. All right. I was looking for both the magnitudes and the directions. So if you had the magnitude right but the direction wrong, that didn't happen very often. But if that happened, then you did not get full credit on this. All right, let's look at multiple choice. All right, here I want to know the capacitance of this capacitor. I recognize the separation is 8.85 times 10 to the minus 6. The area, or kappa, is equal to 1.4, and the area is equal to 0.1 square meters. And then I know that epsilon naught is 8.85 times 10 to the minus 12. So capacitance is kappa epsilon naught A divided by D. That's 1.4, 8.85 times 10 to the minus 12. A is 0.1 divided by D, which is 8.85 times 10 to the minus 6. Looks like I can cancel some things out here, so I'm going to cancel that out. And then this 10 to the minus 6 cancels, just give me 10 to the minus 6. So I get 0.14 times 10 to the minus 6 farads, which is 0.14 microfarads. C1 is connected across a battery of 5 volts. C2 is same voltage, but C2 has twice the area. Remember, so not A over D. So if it has twice the area, C2 has twice the capacitance. And if it's connected to the same voltage, Q is equal to CV. If this is constant, but this is twice as big, that means that C2 with the bigger capacitance has the bigger charge. All right. Plate areas and separations of 5 parallel plate capacitors given here. Well, remember, C is proportional to A over D. So I can think about this in a couple of ways. I like to pick out the biggest and smallest. I'm ranking these from least to greatest. So the one that has the smallest is going to be with the smaller area and the bigger separation. So that would be this one. That one has the smallest. Oh, look, that gives me the answer. Okay. Oh yeah, that was pretty good actually. Let's just double check that I know that we understand what's going on here. So The one with the smallest is 4. Look, it has a over 2 divided by 2d. That gives me a factor of 1/4. This next one says 1. Let's do that. So that's just a over d. So that gives me a factor of 1. Uh, oh, and then 2, it says it ties. So that's 2a over 2d. That gives me a factor of 1. Uh, then 5. 5 is a divided by d divided by 2. That gives me a factor of 2. And then what was the last one? 3 is 2a over d over 2. That gives me a factor of 4. So that is correct, ranked in order from least to greatest. Okay, this circuit, this one has 8 volts right here. If that one, I want to know the voltage across this capacitor. So I know that each of these branches has the same voltage. So if this has 8 volts, this is the bigger capacitor, so it has the smaller voltage. And then 8 plus 4 is equal to 12. That means this has 12 volts, this has 12 volts, and this battery is also 12 volts. What's the voltage on C1 here? Um, I'll draw an equivalent. That might be easier. The 3 and the 6 in series is 2 microfarads, and then so my final equivalent is just 2 capacitors in series that are 6 and 3 microfarads. So I know that this one has 4 volts and this one has 8 volts. We've done that before. Um, that means that this also has 8 volts and 8 volts. What am I looking for? The voltage on C1. That's this 1 microfarad. Oh, so I found that right there. That's the answer, D. Okay. I want to know the voltage across this circled capacitor. Well, this is similar to the one we did before. If this one's 8 volts, this one's twice as big, so that means the voltage is half. It's 4 volts. That means this is 12 volts. By the way, this is also 12 volts, and this would be 12 volts as well. What charge passes through the wire in 20 seconds with that current? I is equal to Q over T. So Q is equal to I times T, which is 0.1 times 20, or 2 coulombs. The statement is necessarily true. The current through a voltmeter is big. No, actually the current through a voltmeter, because the voltmeter has a really big resistance, the current is going to be really small. The current through an ammeter is big? Maybe. It's whatever the current is. So if it's a big current, it's big. If it's a small current, it's small. The voltage across an ammeter is small. So because the resistance of an ammeter is small, which is the next one, the voltage is also small. So it's 3 and 4. All right, you apply these voltages and you get this plot of I versus V. Remember that I is equal to V over R, or I could write that as I is equal to 1 over R times V. And I'm plotting I versus V, so 1 over R should give me the slope. Here the slope is equal to 40 divided by 20, which is equal to 2. So I'd say 2 is equal to 1 over R, so R is equal to 1/2. Which of these statements is correct? Okay, bulb A, well, let's say here. So let's say I have 12 volts here. That means, and 12 volts here. That means I have 12 volts here, and 6 volts, and 6 volts. Remember, the power is equal to V squared over R. These all have the same resistance, but their voltages are different, so that's why I write that equation, as opposed to writing P equals VI, because each of them has different voltages, and each of them has different currents. So that has 2 changing variables, but here I have one variable that's constant, and only the V changes. So um, bulb A has 1/2 the voltage of bulb B. That means it has 1/4 the power, or 1/4 the brightness. Okay, I want to select the resistivity. R is equal to rho L over A. That means rho is equal to RA over L. So I can calculate that rho. Uh, R, by the way, is also equal to V over I, so I have to calculate that R first. V is 1.4 over 20, 1.4 volts over 20 amps. What's that? 0.07 ohms, should be ohms. So rho is 0.07 from Ohm's law. A is given, 7.85 times 10 minus 7, divided by, the length is just 1. That's easy. So 0.07 times 7.85. It's like it's 5.5 times 7 minus 8, so it's that one. Okay, R rho L over A. If I double the cross-sectional area and I have the length, what I get is an R that is 1/4 the original. Rank these 4 bulbs from most bright to least bright. So this one has a voltage V. This one has a voltage V over 2. This one, so this one will be the brightest right here. I know that D is the brightest, but look, they all are brightest. So now I need to figure out which one is going to be the dimmest. Or let's think about it in this way. If these two bulbs split the voltage evenly. If I think about B and the equivalent of these two, I'm going to have one that's a big resistance and one that's a small resistance. That means that these two bulbs, B and the equivalent of these two right here, they will not split it evenly. Instead, the voltage across B will be bigger than the voltage across C. And we need to recognize that the voltage across B would be bigger than the voltage across A. So that means that C is going to be the smallest, which gets rid of all those. So now I have the answer is D is the brightest, B is the next brightest, A is the next brightest, followed by C. Let me repeat what I just said. So this one, these two both carry the full voltage of the battery. Those are the brightest for sure. These two split the voltage evenly, V over 2. These would split it evenly if this one was equivalent to these two, but this one has a smaller resistance than B. So that means that the voltage across this part of the circuit is smaller than the voltage across this part of the circuit. And by the way, it's smaller than the voltage across A. So that means that D is the biggest, B is the next biggest, followed by A, followed by C. All right, what is the voltage provided by this power supply? I know that this is 12 volts right here. Also, the voltage across this part is 12 volts. Recognize that, well, let's write the equivalent, actually. That'll help you. This is 2 and 2, that's 1 ohm. This is 4 and 4, that's 2 ohms. And it has 12 volts. If this has 12 volts, that means this has 6 volts. And if that has 6 volts, that means this is 18. So A is the right answer. What is the current through the 1 ohm resistor? Just really need to draw the equivalent here. 1, and then the 2 and the 2 are 1. And then the equivalent then would be so the current through this resistor is going to be the same as this current, which is 12 volts over 2 ohms, which is 6 amps. All right, which of these equations is correct? 14 minus 4i1, that means I'm starting here and I'm going in this direction because the first one is positive. 14 minus 4i1, so far that's correct, plus 6. Oh, what? that one's the right answer. Let's look at these others. The current, this should say I2 plus I1 equals I3. That's not what it says. 10 plus 6 I2. So 10 plus 6 I2 plus 6. Let's see, that should be minus 6. 14. That should be minus 4I1 plus 10 plus 6I2. Yeah, it would be, if this was minus, that would be correct. Right? What is the current through the 4 ohm resistor? The 4 ohm resistor, that's I1. So I can just solve this equation. 14 plus 6 is 20 minus 4I1 is equal to 0. That means I1 is equal to what? 5 amps. What is the current I? Well, I need to know the current in this little wire right here in order to find I. If 12 is coming in, that means I have to have 10 amps going there, because 10 plus 2 is 12. And then I have 10 amps and 1 amp, that means I have 11 amps. Which of these rules for resistors? A bigger resistor will have a smaller current. Sure. I is equal to V over R. If this goes up, this goes down. Resistors in parallel must have the same voltage. Yep. Must have the same current in series. Yep. If you increase the voltage across the resistor, the current increases. Sure. If V goes up, I goes up. So that's correct too. And then if V equals 12 volts, what are the voltages across A, B, and C? If this is 12 volts, that means this is 6 volts. So I can get rid of that one and that one. This is 12 volts. So I can get rid of anything that is. Let's see, let me correct this. Just a second. Okay, yeah, so there's a typo here. All these should say C right here. Okay. So VC is 12 volts. That means I can get rid of, well, none of those. Oh no, I can get rid of this one. So now it's, what is VB? Well, if these are equal, this is 6 volts. So VB, so C is the right answer for 20. All right, that's the end.